But yes, we'll try to have a little bit of fun together with learning. So I guess right after lunch, you won't feel boring or tired. And then we'll also see some demos to make it a little bit more interesting. So I guess all have settled down, and yes, so let's start with a little bit introduction about, okay, what all you are working on. How many of you have heard of this technology Jmx before? Okay, wow, a lot of people. And how many of you have already used it? Okay, and so Jmx, I guess I will go over the introduction very briefly. Jmx is a standard which is previously it was part of J2E as well as Java SE, but now in Java 5 it's part of SE only, it's part of Java SE only. So it's available as a language feature. So I'll just go and give a brief introduction about this. So before I go into the introduction, I'll just give you the agenda, what it is all about. And I'm going to give you just a very layman introduction to the topic, because the topic is really very advanced and vast. So I'll try to give you some of the features or when to use and what are the advantages, things like that, and also give you some update about what is latest in this. So before we go to this agenda, okay, I would also like to introduce myself. I'm Tarun. I'm Tarun Telang from SAP Labs, Bangalore, and I'm working in this technology since last 3.5 years. And I've seen through some phases of this particular technology, like in the beginning, and yeah, we in SAP are using it. So yes, so the agenda here today is introduction, then a little bit about the architecture, and why or what is the need of JMX, and then I'll go through MBeans. So how many of you have developed really an MBean? Okay, cool. So we have someone who has already developed an MBean. And then I'll go into more details of the architecture, and finally we'll also see some code snippets and also see them working. Okay, so just before starting to the introduction, what I would like to ask you people is to really run an enterprise application, a large application which will be used by many customers across the world, having distributed deployments or installations. What all things are required to really have it running? Generally we write normal program, and are normal program good enough to run in productive environment, or do they require some more features as well? So first thing, we see that, okay, we require support for seeing how well the application is doing. Like you might have noticed that there are lots of web applications these days, and their availability keeps on varying. Today, some site opens fast, tomorrow they are slow, sometimes they are down also. So there is definitely need of tracking. How well is your application doing? Your code would be perfect, the logic and functionality is perfect, but still you need to worry about a lot of things, like whether your application is doing well, or whether the configuration of the platform in which it is running is good enough. So also sometimes there is high load time and sometimes it's low load time. So your application needs to do well in all different kinds of situations. So definitely in your application, enterprise application, there is a need of having configurability or mechanism through which you can administrate your application. and also you can report about how the application is doing. Is it really doing well? Is it consuming right amount of memory? Are there no deadlocks in the thread? So all these things. So this is what JMX is all about. And going into the introduction, so I'll just point out some of the important points of JMX technology. JMX is a standard, okay, and it's an open specification. So anyone remembers the JSR number, Java specification request number of this particular technology, JMX? 3. Yes. So here, if you look into the JSR 77, it's about Java management, J2E management. This is also related to that. JMX is JSR 3, and then you have 160, JSR 160, which is about JMX remoting APIs. Because yes, I told that you require configuration, manageability, administration features in your application, but also you require distributed management capability, because you will a lot of time require to monitor from one place if your application is deployed whole across the world. So you would not like to travel to all different parts and get the status of the server. You would like to sit in one place and see how well your applications is doing. So distributed management is also required. Or remoting capability, remote administration is also required. So these are some of important points. And JMX is not only a standard, it is also a set of services. It's also a set of APIs. It's also a design pattern, how you should create manageability or administration capabilities in your application. Going to the next point, what we have here, a little bit it talks about the Jmx architecture. And yes, this already I have talked about. You require runtime monitoring, management, and configuration support for applications. So Jmx architecture provides interfaces and also a lot of other things like services. There is some services for scheduling, timer, notification. So there are a lot of specific requirements. What features or what services you expect from a management framework, because when you monitor something, you would also like to send notifications. So if my application is going below a certain level of performance, then I maybe send some notification to different classes which will kind of run my application in the lean mode or try to recover this application. So there's also some concept of zero administration. Zero administration is about applications themselves are able to recover from their state. Definitely administrators are required for some permissions, like if you have to restart, then administrators will be required to restart this service, because some users might get logged off. But other features which don't require user interactions, like little bit tweaking around of memory configuration or CPU configuration, number of threads and all these things, could be very easily tackled by application itself. So this is one good feature about that. So now going to the architecture, I'll also show you the architecture diagram, how it looks, how various components interact in JMX. But here JMX architectures consist of 3 layers basically. So definitely you would have understood that, okay, when you talk about management, you will have in administration or management application 3 components. One is the resources, which you will be going to manage, or which you are going to monitor, or which you are going to configure, or which you are going to operate. So you will require resources, and over these resources, what you do, you create wrappers. So these resources could be your services, Java services, your applications, or your devices, mobile devices, and it can also be some other C++ application. So JMX does not restrict you to use only Java applications as a managed resource. You can manage all different kinds of applications or devices or applications, even if they are non-Java application. With help of JMX, you can create monitoring or configuration or administration application for these applications. So your resources need not have to be Java based. Over these resources, you put a wrapper. You kind of encapsulate the management functionality into mbeans. So the second term which I mentioned, some of you might be wondering when I was asking how many people have written an mbean. Mbean is nothing, it's kind of a bean which is called managed bean. Okay, so how many of you have written beans, Java beans? I guess most of you who are Java developers would have known what is Java beans. It's a class, but it follows a protocol. Okay, you have a getter, setter method, and you stick to some guidelines. Similarly, in mbeans, you encapsulate all the management functionality, and you stick to some standard which is very similar to beans. So that's why we call it mbeans. So you require interfaces over your resources or wrappers over your resources, and then also you will require some services which will kind of help you in getting this information faster. And then over that you will require connectors to get this information to the remote monitoring screens. So now I'll kind of show you what all layers are there. So the distributed layers, connectors or adapters, just sitting behind the monitoring screens, monitoring dashboards, which will help you to connect to the JMX modeled or JMX based instrumented resources. So there I'm just throwing out some of the terminologies. So instrumentation, one terminology is instrumentation. When you wrap any resources with JMX interfaces, that resource is called to be instrumented. So here, one more good feature which I forgot to mention is not only JMX will help you in creating Java-based monitoring applications. Okay, one thing which I told is the resources could be Java as well as non-Java. But the application on the top, they can also be Java or non-Java. Okay, you can have your old applications, or say some third-party applications which are not developed in Java, maybe they are developed in C++, your existing dashboards, you can configure to connect to JMX and pull data from JMX. So this layer on the top is connectors and adapters. And agent layer I already talked about is you also require services. And here one more important thing comes into picture is mbean server. So mbean server is also kind of a container, like you have EJB container or web container. Similarly, mbean server is a part of agent layer of JMX, and what it does, it takes care of the instantiation of mbeans, and all the access to the mbeans is through this mbean server. So I'll talk about more over this topic in detail later, but what I'll go over to next is the third layer, which is instrumentation layer. So this is just mbeans or managed beans which are encapsulating the resources. So I guess now you might have got a little bit of idea about the topic. So am I making sense? Say okay, yes or no? Yes, okay. And how many of you are feeling sleepy after the lunch? No one? Oh, great. Okay. So this I have already covered, yes. Java SC and Java EE. It's part of both the specifications, and it's available in Java 6 as well. Okay. So here is the complete picture. If you see, here is the MBean. Okay, MBean is nothing but a representation of a resource. Then you have MBean server over the top. And services. Some services might be required because you might require caching, because these MBeans could be distributed. So here you see, there are different JVMs or there are different machines or systems could be there, and from that you kind of retrieve information. So over the MBean server, you also require protocol adapters or connectors, because you would like to communicate to your information or this monitoring or configuration information through either web, that is HTTP or HTTPS protocol, or you may access it with RMI protocol, or if you use your user-defined or customized protocols, then you can write your own connectors or adapters over that. So over the top you see these are the applications. So you can have Jmx complaint management application, which is very easy, means you don't require any connectors or protocol adapters. What you get all these by default implemented by Sun, or in some cases you may require to write your own adapters or connectors if they are not available from Sun or some other third-party vendor. And here, okay, if you are running a proprietary management application, some existing application, then also you can write just a thin layer between that to convert the JMX kind of information to your proprietary managed application. So just a little bit of converters you need to write. So that is what I wrote here, JMX Manager. And definitely from one place you can monitor multiple resources at different locations. So is the architecture clear? Fine, I guess it's very simple, 3-layered architecture. And now coming to, okay, why this particular standard? Okay, and what are the benefits, or why you, when and where you will decide, okay, when to go over JMX. So here JMX is suitable for adapting legacy systems. And I'll also show you it's very easy to implement. It's not that you have to write too much of complex code. So this has been taken care that if you have lots of existing applications, then you can very easily convert them and put management layer over the top of these applications and then monitor and configure these things. So you can get monitoring or configuration capability over that very easily. And it's also useful for implementing new solutions for monitoring and management. As I already told that the new applications, there will be lots of critical business processes which will be running on IT infrastructure. So definitely you require need of having monitoring or management capability in all of your applications, because you will not like to have your application not running well and you are not aware of that your application is not running well. So definitely management and monitoring is very, very important. Then it's also suitable for plugging into future applications. So, okay, this thing in Java 6 or even in Java 5, you by default get a lot of management capability by default. So if you have a Java complaint server or Java engine running, J2E engine running, then you will automatically get lots of monitoring and management capabilities. There will already be lots of MBeans. So to just pick information. You need to connect to this ambience and get to see the details of how your application server is doing. So what all things have to be monitored or managed in a Java engine. This is specified in JSR 77, which is about J2E management. And yes, one more thing I will tell you, in Java 6 it has become very simple. So by default all Java applications will get this management capability. And now JMX is used to provide application management. For this I have already told, if you have a web application, definitely you require monitoring and configuration capability. So web applications are candidate for monitoring. Standalone applications, definitely. If you have an application like an IDE, Eclipse-based IDE, then yes, performance of your PC is also important because your productivity is based on that. Or also there are lots of important standalone applications which you will definitely like to see how they are performing. And then application servers, yes. Because there are lots of applications, so if application servers are down, then definitely your applications are not doing well. So another example of a standalone application, you can say operating system. Definitely you would like to monitor operating system. Then services, yes. So services, web services, and other kinds of services which are available, definitely you will require to keep an eye on how they are doing. And then devices, Java enabled devices. So if you have a barcode reader or RFID device, then definitely their availability is important, because if RFID based devices are not doing well, then you will not be able to get information about your goods or whatever thing they are attached to in a proper way. Okay, so this is again coming back to JSR 77 J2E management. Whenever you have a EJB or a JMX kind of application, you automatically get lots of management features inbuilt, and what you need to do is just tap into that and get information which would be useful for you. So these things, okay, I've already talked about. Monitoring the application server and configuring the runtime environment of your application. Okay. So now we will come to the point that ambience, and enough talking, and we'll also see little bit of demo and code and how really it looks like. So ambience is nothing but managed Java objects. They are similar to Java Bean. This I've already told you, and it represents a resource. And resources are instrumented by ambience, and they have a set of interface. So lots of monitoring information. You will, yes, you will kind of provide two kinds of operations or two kinds of properties that you would like to expose. Some properties you would allow your administrators to configure or to write into or change the value of. And some properties you would only like to display it to the administrators. So any example of such kind of property? Say number of threads. This is a configuration thing. You can increase number of threads or heap size. If you say maximum heap size, you can configure. So you would like to allow your administrators to change the maximum heap size. But used memory, this is unchangeable thing. This you only need for monitoring. But maximum heap size is something which you need for configuration. So with the help of interface, right, kind of interface definitions, you can allow or disallow some of the features. So how you make a particular attribute read only by just exposing the getters. You don't put the setters in the interface. So that is not available to the application or whoever is the client of that particular interface. And I have told you that all mbeans or all managed beans can only be accessed through mbean server, because mbean server takes care of instantiation and takes care of all pooling, connection pooling, or different services are available, and your call is delivered in a reliable way. So you require a reference, and the reference is an object name. So all mbeans have an object name, and object name has to be unique within one JVM, okay? So, or within one system. So object name is some name. The format I'll show you later. So getters and setters I've already talked about, because these are required when you want to expose some functionality, expose some operations as read-only, or you have to give read and write, then you expose both getters and setters. If you want to make it only read-only, then you just don't expose setters. And then you not only have just attributes exposed, but you also have operations like restart or shut down, stop. These are operations which you perform on resources. And also when some administration or administrator will like to access these operations or attributes, if you expose just technical names, it will not be good enough. You also have to describe your functionality. So when you say restart, maybe administrator would also like to see what actually this restart mean. Is it the complete restart of the server, or just the restart of application, or just restart of the portion of application, or just one service restart it is referring to. So when you define mbean interface, or you expose a resource as a mbean, you provide all these details. You provide the object name, you provide the attributes and make them read-only or read and write. You define operations, and you also give descriptions to all these things. You describe the interface, describe the mbeans, describe the setters and getters, describe the operations on them. So these all descriptions are required. And object name is a kind of a string, or it's a name, like you have a URL. How do you access a web page? You give the URL of the page. In the similar way, how you will access an mbean, you will give object name of the mbean. And you can not only give object name, you can give a object name pattern. Say, for example, I'll give you an example. Different mbeans, there is not only just mbeans do interact with each other. Because if you see the real resources, you have a lot of things, like take an example of J2E's server. So servers will have instances, server, you will have a cluster, and then you have different instances, and in these instances you will have different services running. So there is a hierarchy. So maybe you can search. And generally when you design these mbeans, you create the complete design, and you create hierarchies, associations, various instances are associated to servers is associated to cluster or application server, and maybe then over top of this you have some products, like okay, you have supply chain management or enterprise resource management or whatever. So there is a complete hierarchy of associations. So sometimes it's also required to search, okay, what all, so when you see administration console, so sometimes the requirement could be administrator would, or applications would first make a query. What all resources are instrumented over this application server. So these applications can query and then they get the list of resources which will be instrumented. And then out of that, then they can query what all operations and attributes are available, and then you monitor or configure them. So this is the way it is implemented. So pattern-based object names are also allowed, and they help you in searching these. And then the domain, this one is an example of object name. So you have a domain. The object name looks like domain. It could be like com dot some domain name, com.sap or com.sun, or domain is just a kind of namespace to group your resources. And then you have properties. So type, maybe one example is type equal to server, Java server, J2EE server, like this, or type equal to memory, type equal to threads. So you can have multiple properties of a mbean. So you kind of construct a name. So here is an example. So com.example.mbean, then you decide to uniquely identify this particular resource. So for example, to uniquely identify this particular presentation, what I require? I require, so key properties, if I try to list out, one of the key property is the name of the presentation, say Jmx presentation.ppt. Then second thing which may be required is the folder. Key property 2 is the folder, which folder it is, then which machine it is. So these are the key properties. So if I want to name my PPT, if I want to create an mbean of my PPT, what I need to do, I need to identify what all properties I would like to monitor. So first property is how much memory it is consuming. The presentation, it should not happen, system goes down and hangs. So I would like to put, okay, attribute used consumed memory as one attribute. This is definitely a read-only attribute because administrator would not like to change these values. So this is only, I'll expose only getters, not setters. And then I'll create an object name which will be com.example.mbean and then key properties, which I already talked about. So here is the code example, one of the code example, and here I show the implementation and interface. So here, as you see, now if you want to manage or make some application configurable, what you need to do, this is a simple class. Okay, here this particular class tries to create a monitoring application for memory. So what I do here is I expose an interface out of this. And here I have said used memory is read operation, and set used memory, that's write operation as well on this particular. And you provide the size. This I just gave for example. And then you have the total memory, and then calculate free memory is an operation. So it's just an example. So I'll show you how to run it. So I'll just switch over to, I'll show in the command line. The code. Okay. So the code, it's simple class, nothing is special about it. Since now these mbeans are part of the language itself. Okay, I'll run this code in Java 6 and also you can run this in Java 5. So here if you see there are no import statements. First statement is just okay, public class. So I'm not using any extra feature of Java. They are just language features. And what I do is, but just look into some naming conventions. The class name is memory, okay? Class name is something which will represent the resource. And interface name, which I'm implementing, is class name followed by mbean. So this name itself will give information to the JVM that I'm trying to create a mbean. Okay. And then remaining thing, okay, here I have a constructor and I just call some Java APIs to get the memory of the JVM. How much you get, means how much is the total memory, used memory, free memory. So these are the things. So now let's see what happens and how I'll run this. And we'll also try to correlate with the architecture which I have shown you. Okay, so maybe I'll just show you the complete code. Here down, it's nothing, it's just classes and some simple functions to get the memory. So here what I'll do is I'll run this. Okay, no, but before that I'll show you interface and agent also. Okay, so this is my interface. Only thing special about this interface is the naming convention. It's called mbean, memory mbean. And then I told you I have to also describe what all is there in the mbean, and I also have to register it to mbean server. So I'll show you the registration code, how I will declare to the mbean server that this is an mbean and I will like to later call this particular application to get some information from this. So here is a part of code which is called registration code of. Okay, so here something special is there. You have some package java.lang.management and javax.management. Okay, so here if you see what I am doing, this is an agent. This agent, when it is running, that means you will have the ability to see into what memory is being consumed. So this agent is something which will try to collect information from mbeans and give it to the applications or clients. And here if you see, I have also declared that object name. Object name is, I have to just scroll, is com.developer-summit. It's also like URL because it's user-friendly name. So my object name is domain, comma, key property, memory. So this is a standalone application and I'm just monitoring it from the same PC, so I don't require other details. But if you want to monitor memories of lots of systems through one console, then definitely will provide more details or more key properties would be required, like the system or what kind of application the memory is associated to. So you can have more key properties. So other key properties will be separated by comma. So this is the object name, and then what I do is I create memory mbean is an interface. I create a new instance of memory, which was a simple class I showed you before. And then this is mbean server.register mbean. Is what you do, I provide with registration the instance as first parameter and the object name as second parameter. And then I just make this agent waiting so that you can keep on calling the mbeans. If I close it, then also the object will vanish and you won't be able to see the memory details or properties of the memory mbean. So I'll just keep this particular class running long. So this is the code about how to register. So now here if you see, this is a kind of service. It's an agent for my mbeans. Now I'll run this. It's running. And one more thing, what Java 6 provides, it provides you with an example monitoring application, which is called JConsole. So if you have anytime looked into the directory, bin directory of the JDK, then you will find there is a exe which is called JConsole. So I'll try to run this JConsole. So here you can just see the path. It's normal Java JDK, and then I just type JConsole here. And what I get is a swing-based application, which is a kind of default client or default dashboard for monitoring. And here you see my memory agent. Because it's running, it also automatically detects what all different agents are running. And in my PC, I'm also running, see here, I have Eclipse running actually. So here it shows, okay, would you like to monitor Eclipse or memory agent or JConsole? JConsole is anyway, again, this same application. So if you want to monitor itself, because it's also a swing application, it comes into the list. So I'll select memory agent. So I say connect. Okay. Now it's connecting to memory agent, and it will give you lots of information. Other tabs you see is generic. So here overview tab and all these has to do with just a minute. These all tabs have to do with the normal functionality or normal monitoring of JVM, but what I have here is ambience. And then you remember the object name which I gave was com.developersummit.ambien. So here is the com.developersummit.ambien domain. And within this domain, I have my ambien, which was called memory. And interface was ambien, memory ambien. So if I select this, here if you see, I have the object name, the class name is the Java class name, and also description. I didn't give means anything in the description, so it took the default description. But it's also there is also possibility that while you are writing code, you can give description. So there are APIs available while registering or before registering, you provide the description, and here is the attributes. So I gave two attributes. One was read-only attribute. So if I kind of select it, it shows the chart also, but it's anyway not varying, it's some constant value. So I get this. So here I use the API to get the total memory. So here you see the total memory. And used memory is something which will be varying, and that's why I kept it as read and write both. So if I double click here on this attribute, I get a text box to edit this. So I can change it also. Say this is some configuration feature for my administration application. So I hit enter and now it's changed. And now if I go into operations, I have one operation which is called calculate free memory. So these are automatically picked up. All these functionalities are picked up from ambience by this particular administration application, which is JConsole. So when I call this particular method, it calculates free memory. Okay. So now it also updates the free memory. Last time I gave some junk value, but here it really calculated the real amount of memory consumed, and it has updated also the used memory. So this is an example of ambien. So if you can try to kind of correlate with what I have said previously, I said in the Jmx architecture you require a resource which has to be monitored. In this case, resource was the real RAM or the memory or Java heap of my PC where the JVM was running. And then I require on top of that MBean. So yes, I have instrumented memory. I created a class called MBean and then I wrote the functionality to get the details of the memory. And then I create an interface through which I expose what all operations, attributes are available. And I created a service which was kind of an agent whose work was to create a new instance of my MBean and register it to Jmx server. So here that agent is running, and that's why my Jmx compliant client or my Jmx compliant dashboard, which is JConsole, is able to pick all the attributes and operations of MBeans. And then if you want to see some generic information which comes by default with JVM is memory usage, the number of threads you are seeing on the right side of the top. Then here you have number of class loaded and CPU usage. So you get lots of other details as well. So you see here graphs. So if you can also write plugins to this particular JConsole, or you can write your own dashboards, maybe using servlet or any UI technology to create such things. But what is underlying what is the instrumentation layer is MBean. So this is that is what you specify using Jmx scenario. Okay, where you're saying this java.exe. Okay, so here the figures which we see is java.exe is taking 15260, and here if you see used is used committed max. Yes, because this is I guess this details, maybe I'm also not complete expert to tell you why the consumption here. Yes. Okay, yes. Okay. Okay, it's coming 6.4. Yes, presently. Yes. So the remaining memory maybe this particular thing. Anyone has the answer because I asked.
Whatever that we are seeing through task manager is an instantaneous value. Whatever that is getting consumed by Java.exe.
Okay.
Is the size of -8mx parameter.
Okay.
That comes to the JConsole. This is the maximum amount of memory that JVM process can,
Yes. Yes, definitely. So here he got a really good explanation for that. Maybe this java.exe is something which operating system has allocated for this particular process. And this, what you are seeing, is what is really being used. Okay, so this is the exact thing, but that is something which is allocated.
So not everything is being used.
Yes.
The minimum heap size.
Yes.
I have a couple of.
Okay.
Can you show me that memory MBean interface?
Memory MBean interface, I'll show. Okay, this is the interface. So here we have already seen that total memory that was not editable. Yeah.
So there through the JConsole you have under operations tab, if you go to the JConsole.
Yes, I'll just go.
Operations tab.
Okay.
So only one method is exposed, calculate free memory, not the setter, right?
Yes, just a minute. So first is, okay, you are saying only calculate free memory is exposed, but these other methods,
Set used memory should also be exposed.
set used, get total memory.
Everything should be.
Yes, everything should be there, but they are not, because these are the getters and setters method.
Okay.
So get used memory, how they are exposing? Get used memory is you are getting the value of used memory here.
Okay.
6284075
Okay.
So they are not operations, they are setters and getters of the attributes. So they don't display, they are not getting displayed separately. So here the difference is used memory, if you see here, used memory has both setter and getter. That means it could be written, this value could be changed, and you can read also. So here you see, you can change it also. Okay.
Yeah. Go to the class, memory class, that implements memory ambient interface.
Okay, yes, so memory class is this one.
Just go up.
Up and here.
Private count total memory. Yeah.
So here if you see, this is a property, used memory is an attribute. That's why get used memory is a setter and getter method, and then this is the setter.
Yeah.
Okay.
Yeah, I got answer to my question. Another question was in every, any servlet container kind of a thing,
Yes.
like in Apache Tomcat, whatever the kind of MBeans exposed via this,
Yes.
say parameters and attributes for database connection, full size and all that.
Yes.
So whatever the changes you will be doing through, suppose a kind of a connector service or through JConsole,
Yes.
is only at a runtime. There is no persistent storage for this.
Yes.
Isn't that?
Yes. Okay.
So I mean, if you are in runtime, if you are changing your database server
Yes.
from one particular server to the another, so that won't get reflected into your server.xml if you actually stop the server and then restart it.
So here, all the changes what you do is only for that particular session. Till the session is there, you are able to see these things. And once, if you are not persisting the information, so you have to take care of storing it into the database. If you don't do that, next time when you open this, it will be gone.
Yeah.
So I change it to date something, and then I close the application, and if I open it again, then it's gone. So if I write some code which will store it into the database, and while reading retrieve from the database, then it will be retrieved. Otherwise, yes, it's the same way as in other cases.
And the thing is, you didn't cover the different type of MBeans.
Okay. Okay. So yes, maybe I can cover you orally the different types of MBeans. So there are different types of MBeans, and one type is the standard type, which is this one. So the interface is static here. Once this interface is defined, it cannot be changed. But there is also feature where interface could be changed at runtime. So that kind of MBean is called dynamic MBean. And in that particular scenario, the MBean server detects the interface using reflection. So that is second type of MBean, which is dynamic MBean. And then there is a model MBean. Model MBean is something which is standard MBean, already modeled by JVM. So you need not have to create your own MBean. You can use from the existing set. And then open MBean. Open MBean is kind of combination of both the model MBean and then dynamic MBean. And then there is something also available in the latest release of JMX, which is in Java 6. You have MX Bean. MX Bean is MBean which can take open types. Actually, I told you, since the time is also not, 1 hour time is not too much, because this entire topic is very vast. So one thing which MBean framework takes care of is when you expose these operations, the data types, it is open types. The advantage of this open type is if you are using a non-Java client, because if suppose you are using a class which is custom defined or user defined class, then that particular class could not be understood by C++ client or maybe some other HTML client. Or so what Ambeen server does, it kinds of exposes information in the form of open types. But creating open types is not that easy. So MXBean takes care of automatically converting your custom types to open types.
So in case of dynamic ambience, how will you actually change your interface at runtime? I mean, what's the way, how to use that?
Okay, in that case, yes, you at the time of registration, you can re-register.
Okay.
Okay, you create different classes and then you re-register it with different interfaces.
Yeah, thanks, Tarun.
Okay, so yes, so what else I have is anyway already covered, because here there's a lot of simplification in Java 6. So if I go to Java 5, I have to run an agent with this particular descriptor, Java then -d com. So if I use -d and then this particular option, then only I will be able to see the agent in JConsole. But here in Java 6, this has been further simplified, and you just type JConsole, and even if I'm running my agent, Java memory agent, it is detected by JConsole. So here if you see, okay, here Java memory agent. If I just type this Java memory agent, it works in Java 6. But in Java 5, you have to type Java -d com.sun.management.jmx remote and then memory agent. Then only it will be detected in JConsole. So here just for notes, different operations which could be done on the Ambeans, because one thing I'm again not covering is creating your own clients, how you will call through code Ambeans. So I just demonstrated, because we are a little bit short of the time, so I just demonstrated an existing client and how it is consuming an Ambeen. But yes, you can develop your own client like JConsole, and code snippet is there. Querying an Ambeen, access to an Ambeen, and then also invoking an operation. So some of the references here I've already talked about. The Jmx homepage, if you want to get more details, the details are available in java.sun.com. I'll read you because the font is not that visible. So the Jmx homepage is java.sun.com. I guess everyone is aware of Java soft web page, and you just type /jmx, you get the Jmx homepage. So a lot of information is available in Sun website, and then you can find an introductory article on Jmx on SAP Developer Network. That is posted by me but 2 years back. So here is the link, and then other resources is JSR 3 and JSR 160. And how to get them is JCP, javacommunityprocess.org, jcp.org, then en JSR, then detail ID equal to 3, and here ID equal to 160. So JSR 160 and JSR 3 are the JSRs or Java specifications which are relevant to Java management extension. So with this, I kind of conclude my presentation. Thank you very much.